Okay, I want you to picture something for a second. Think about a machine, built way back in 1977. I mean, by today's standards, that's practically ancient history, right? It's a museum piece, a relic. But what if I told you that right now, that very machine is hurtling through interstellar space? And not only that, it's still working, it's still talking to us, after almost half a century out there in the void. Now, this isn't science fiction, not at all. This is the absolutely incredible, true story of Voyager 1.
I mean, to really get your head around what a miracle this is, just look at this comparison. Voyager's computing power, it's millions of times slower than the smartphone you're probably holding right now. Its memory, we're talking less than what's in your car key fob. And get this, for data storage, it's using an 8-track magnetic tape. I'm not kidding. It is, by every single measure, a total antique. And yet, this thing is out there, boldly going where nothing from Earth has ever gone before.
And how far out are we talking? Well, right now it's over 23 billion kilometers from us. Just try to wrap your mind around that number. A signal from Earth, traveling at the speed of light, the fastest thing in the universe, takes almost a full day just to get there. One way. And the whole time, for decades, it's been surviving this constant storm of cosmic rays and the unimaginable cold of deep space.
So yeah, that leads to the big question, right? How is this even possible? How does a piece of 1970s tech survive all of that for so long? Well, let me tell you, it's not luck, not even close. The answer comes down to 3 absolutely brilliant, you might even say prophetic, design choices that its creators made way back when.
All right, so the first secret, the first piece of this puzzle, all starts with its power source. You have to remember, back then, everyone was all about solar power. But Voyager's engineers, they went in a completely different direction. They made a rebellious and honestly a very expensive choice. They gave it a nuclear heart.
So how does this nuclear heart actually work? Well, first off, it's not a nuclear reactor, so don't picture that. It's something called a radioisotope thermoelectric generator, or RTG. A much simpler way to think of it is like a nuclear battery. It's powered by the steady, predictable heat that comes from the natural decay of plutonium-238. And the engineers knew this was the only way to go. Why? Because where Voyager was headed, way out in the solar system and beyond, the sun becomes just another tiny, dim star in the sky. Solar panels would have been totally useless out there.
And you can see just how reliable it is from these numbers. At launch, the RTG was putting out about 157 watts of power, enough to run a couple of old-school light bulbs. Now, nearly 50 years later, it's still generating around 80 watts. That's the magic of that plutonium-238. It has a half-life of about 88 years, so it's this incredibly slow, perfectly predictable decay that has given Voyager a reliable trickle of power, just enough to keep its most vital systems running for all these decades.
And here's the kicker. The official mission was only supposed to last for 5 years, just a quick trip out to see Jupiter and Saturn. But the engineers who built this thing, well, they were dreaming a lot bigger. I love this quote. They were officially given a 5-year mission, but they secretly packed supplies for half a century. They built it to last, giving it the energy it needed to go on and become the absolute legend it is today.
Okay, on to the second piece of brilliant foresight. This one was all about having a backup plan, and I mean a serious backup plan. In fact, you could almost say they didn't build just one Voyager probe. They basically built 2 and then crammed that complete second life into a single spacecraft.
I mean, just check this out. Almost every single one of its 11 science instruments had backup circuits. It launched with 16 thrusters, and get this, 8 of them were designated as complete backups, just sitting there. Now, at the time, people actually criticized this. They said it was wasteful, that it added too much weight and cost. But as we're about to see, history would prove that this wasn't wasteful. It was absolutely visionary.
And that vision was put to the ultimate test back in 2017. It was a real nail-biter. After 40 years of firing constantly, the main thrusters, the ones used to keep the probe's antenna pointed right at Earth, they started to fail. Now you gotta understand, if Voyager can't point its antenna at us, we lose contact. Forever. Game over. So in a kind of last-ditch effort, the engineers decided to try and wake up the backup thrusters. Thrusters that had been dormant, frozen solid in deep space for 37 years. They sent the command, and then they just had to.
For 19.5 agonizing hours, the team on Earth waited for that signal to make the round trip. Imagine the tension. And then, the message finally came back. Ignition successful. They worked. After 37 silent years, the thrusters fired perfectly as if not a single day had passed.
The mission was saved. Just, wow, what an absolutely breathtaking moment.
And again, this wasn't some lucky break. This was pure intentional design. It worked because those engineers, back in the 70s, used the most durable, most corrosion-resistant materials and the most robust designs they could possibly imagine. Just like the quote says, they assumed the worst-case scenario, which earned them a second chance 4 decades later. Amazing. But, having all the power and spare parts in the world is totally useless if you don't have a brain to control it all. And that brings us to the third and final piece of genius foresight, Voyager's unbelievably resilient and autonomous mind. Remember that nearly day-long communication delay we talked about? Well, in a crisis out in deep space, waiting for instructions from Earth is pretty much a death sentence. The engineers knew this, so they designed Voyager to think for itself. If it ever gets lost, if it loses its lock on the sun or a key guide star, it doesn't just sit there and drift waiting for orders. Nope. It automatically goes into a protective mode and starts scanning the sky all by itself to figure out where it is and find its way home.
This old saying just captures the design philosophy perfectly. When a general is in the field, he need not accept all orders from the king. Voyager was built to be that general. It's out there on the front lines, empowered to make its own critical life-or-death decisions without having to wait for commands from the distant king back on Earth. And that autonomy is precisely what's kept it safe on its incredibly lonely journey all these years.
And this brings us to one of the most fascinating, kind of counterintuitive parts of this whole story. We can laugh at its old magnetic tape storage, right? But here's the thing. That so-called primitive technology is actually one of its greatest strengths. See, modern solid-state drives, like in your phone or laptop, are super vulnerable to all those high-energy cosmic rays out in space. They can get zapped and have their data corrupted in a split second. But Voyager's old-school, clunky, mechanical tape recorder, it's tough as nails. It's way more resistant to that radiation. It just goes to show you, sometimes the oldest tech is actually the most resilient.
In this incredible drive for resilience, this over-engineering, it runs through every single part of the probe. There's this amazing story from 2018. To save a little bit of precious power, engineers decided to shut off a heater for one of the science instruments. Its temperature then plunged 70 degrees Celsius below what it was ever designed to handle. I mean, by all rights, that instrument should have been a goner, dead. But incredibly, it just kept working, flawlessly. It really shows that the engineers weren't just building it to be good enough. As this quote says, their standard was for immortality.
So there you have it. A nuclear heart for power, a complete backup life for emergencies, and a resilient, autonomous mind to guide it. That's how Voyager has survived. But every journey has to change course eventually. So what is the ultimate legacy of this incredible machine, now that its main exploration phase is over?
Well, the reality is that sometime in the next decade or so, probably around the 2030s, its nuclear battery will finally decay to the point where it just can't power its instruments or its transmitter anymore. And when that happens, its voice, the one that has been calling out across the cosmos for more than half a century, will finally fall silent.
But, and this is the beautiful part, when that final whisper fades into nothing, that's when Voyager's true final mission begins. With nothing left out there to slow it down, it's just going to keep on drifting through the Milky Way galaxy for millions, maybe even billions of years. A silent messenger, carrying its golden record. It's truly a message in a bottle, cast into the cosmic ocean from a world that, by then, might not even exist anymore.
And that really is the key takeaway here. The end of its scientific mission isn't its death. Not at all. As the quote says, its journey as a messenger of civilization is just beginning. It's shifting into its final, timeless purpose, to be a silent ambassador for humanity, a tiny, floating testament to a species that, for a brief moment, dared to reach for the stars.
And so, that leaves us with this one last, profound, and, to be honest, almost chilling thought. In the truly vast expanse of cosmic time, billions of years from now, when our sun has burned out and our own planet is long gone, could this tiny, ancient machine be the last, lonely piece of evidence that our civilization, that we, were ever here at all?